Hi folks, this is Mr. Fiducia. We're talking about Unit 3, and in Unit 3 we're going to learn how to construct confidence intervals around a population mean and a population proportion, and I thought I would show you an example. What we have here is a list of some 67 different cereals along with their manufacturer and the number of calories and sodium and so on and so forth that are in each serving. And so I just thought, for example, we would like to determine something about sodium. Suppose we wanted to know the average amount of sodium in these 67 different varieties of cereal. Well, what we would do is here's sodium right here, we would highlight that column. Then we would go to data and data analysis, which I hope you have installed on your Excel. If you don't, look at live binders, it'll tell you how to do it. Then go to descriptive statistics, hit OK, and make sure you include summary statistics. Summary statistics. We did not include the label in the first row, so we don't have to do that. And the input range goes right here, and that's what we already shaded in, but let me do it again. Well, I guess I'm going to have to start from scratch here. Let me get rid of this. Okay, let me go back to data, data analysis, descriptive statistics. Okay, here's the input range right here. The input range is going to be sodium, this column right here. That is inserted into our data analysis right there. Okay. And then what we're going to do is we're going to click on the what we want in data analysis, and that is summary statistics. Okay. And here it tells us, let me widen this for you. It tells us the mean, 167.3 grams of sodium, or milligrams, whatever it was. The median, the mode, standard deviation, variance, and so on, and I said there were 67 of them. Now, that mean, 167.31, is a single number. And we can't put much confidence in that because it's just a single number. What we're going to do is we're going to, in this chapter, learn how to rely more on a range of values instead of a single number. So what we're going to do is we're going to say that we think that the population mean number of milligrams of sodium that's mu, is going to be greater than some lower limit, and it's going to be less than some upper limit, and we're going to attach some percentage or some degree of confidence to that statement. And the reason we're going to do that is because we feel more comfortable with estimating a range of values with a confidence like 90% confidence or 95 or 99 than we are just a single point estimate, the average that we got through data analysis. So the way we're going to do that is we're going to look at the sample mean that data analysis gave us, and then we're going to add and subtract to it the error term called E. And you must have an error term because remember, these are only 67, a sample of 67. You know, there's many more brands and types of cereal than this. This is only 67. So we're going to compute this error term, and the error term is going to be added and subtracted from the sample mean to come up with the lower limit of the confidence interval and the upper limit. Now, there's an easy way to do this. I'm going to show you how to do it right now. What we're going to do is we're going to, once again, go into data analysis. And this time we're going into confidence, if I can find it. Oh, yeah, descriptive statistics, there we go. Now, you notice down here, confidence interval for the mean, it's got 95%. We can change that to whatever we want. But the confidence interval from the mean, if we click OK now, is going to tell us that the confidence is 19.655. That is our error term. Our error term here is 19.655, and that's what we are going to add to and subtract to the sample mean. Remember, I said x bar plus or minus the error term. And the error term here is 19.655. And so our sample mean was, it's got it right up at the top there, 167.31 plus and minus. And so let's get our calculators out and let's see, 167.31 minus 19.655 gives me 147.6. 147.655, that's the lower limit. We say that the population mean is going to be greater than that, but it's going to be less than 167.31 plus 19.655, which is 186. 186.965. So this is the 95% confidence interval. What that says is we're 95% confident or sure that the true mean milligrams of sodium in a cereal will be greater than 147.655, but less than 186.965. So you see, it gives us a range instead of giving us just a point estimate, like 167 with no confidence. It gives us a range, and we can make this statement with 95% confidence. Now, if you want 99% confidence or 90% confidence, those are the three that are generally used most often, then all you have to do is go back to data analysis, and where it says 95% confidence interval, insert 90, insert 99, and your margin of error, remember that's what this is, the margin of error will show up, and then you add and subtract that to the sample mean. Now, if you have pH stat 2, it'll give you the entire confidence interval. I've been having problems with it. I don't know if you are or not, but you can try pH stat 2 with the same information, and you should get this same answer. Now, another topic. The other topic is we may, and you will, need to solve a different problem. In this one, you need to find the minimum sample size that is needed in order to achieve a degree of confidence with a certain amount of error. Let me say it again. Here, we're not looking for a confidence interval. We're looking for a minimum sample size that is needed. Now, the important thing is to, again, I stress this all the time, for you to read the problem carefully. Read the problem carefully. And the reason for that is because that helps you determine what formula to use here, what formula to use. And in this case, what we're going to do is we're going to look at this problem, and it says that Nielsen wants to estimate the mean number of hours, the average number of hours that high school students spend watching TV. And they know that they're willing to accept a margin of error of a quarter of an hour, 0.25 hours. They know that. And from the past, they have found that a population standard deviation of 1.7 hours is reasonable. So they want you to estimate the minimum sample size required. That's the key. They're asking you to find n, the minimum sample size required. Well, here's a formula for the mean number of hours. That's what's important. That this is for mean number of hours. The formula is pretty easy. It's z sigma over E all squared. Z is simply a number based on the degree of confidence you want. Now, it doesn't say here what confidence. So if it doesn't say, then you always use and assume 95% confidence. So for 95% confidence, you always use z equal to 1.96. If it tells you you want a 90% confidence in your results, you use a z of 1.645. And then the third one, generally used, is 99%, use a z of 2.575. So here we know z is 1.96. Sigma, the standard deviation they tell you, is 1.7. And the error is 0.25. In other words, you're willing to live with a margin of error of 0.25. So simply multiply z times sigma, divide by e, and then square the whole thing. And you're going to get your answer. Let's see, if I do that, I'm going to take 1.96 times 1.7 divided by 0.25 squared. 0.25, by the way, 0.25 squared is 0.0625, 0625. So we have 1.96 times 1.7 divided by 0.0625. And don't forget, what you have to do is you have to square that whole thing. And when you square it, it comes out to be about 185. It depends on how close you are to, z is 1.96. Some books use 2 instead of 1.96. They round it to 2. And so, your answer could be a little different than mine, but nevertheless, it's z sigma over E all squared. I came out with 188.2, but the important thing to remember is if you come up with the same answer, 188.2, you always increase it to the next whole number, 189. You always increase it to the next whole number, which is 189. So no matter what your formula tells you, if you, and you will come up with a decimal, even though it's 0.2, you always raise it to 189. Now with the second one, same kind of a problem. What sample size must have been used? But the big difference here is they're talking about a proportion of things, a proportion of things. They say that this poll said that 61% of all households have a computer, and the margin of error they know is 3.5 percentage points. Percentage points. And so they want to know what sample size must have been used in this poll. Well, the expression that you use is pretty simple. It's just 1 over e squared. For 95% confidence, you use 1 over e squared. And most of these will be 95% confidence, by the way. So e is the amount of error, which is 0.035. Be careful because this says 3.5 percentage points. So 3.5 is 0.035. So if you take 0.035 and you have to square it, multiply it by itself, and then divide that into 1, 0.01225, you will get the approximate number. I think it's 816.3, 816.3. But remember, you change that to 817. Always round up to the next whole number whenever you're finding minimum sample size. If you have any questions, email me, afiducia@kaplan.edu. We're going to follow this up with another short video on scatter diagrams and correlation coefficients. So look out for that one.